So the next thing that we're going to look at is something called a conjugate acid and also a conjugate base. A conjugate acid is defined as the molecule that is made after a Bronsted base gains or accepts a proton, an H+. And a conjugate base is the molecule that we get, the molecule that is made after a Bronsted acid donates or loses an H+. Let's look at an equation. Let's use HCO3 minus reacting with H2O, and that's going to make CO3 2 minus and H3O plus. So same thing as we did before when we were just trying to identify what's the acid, what's the base. We're going to pair up a reactant with a product. We're going to start with HCO3 minus and ask ourselves, look over here on the right side of the arrow, what is HCO3 minus turning into? It most closely matches CO3 minus. And how did it go from HCO3 minus to CO3 2 minus? It lost a hydrogen and it lost a positive charge. That makes it the acid. And the molecule that it turned into, CO3 2 minus, that is our conjugate base. Again, the molecule that it turns into is the conjugate base. Let's do the same thing for water. H2O, we know that it is turning into H3O plus. So there's the pair. How did it transform from H2O to H3O plus? It gained an H plus. Because it gained an H plus, water is a base. And because it turned into H3O plus is our conjugate acid. We can also say that the acid, in this case HC3O minus, and the thing that it turns into, in this case CO3 2 minus, we can call them conjugate acid-base pairs. And same for our other reactant, H2O, and our other product, H3O plus. They are also, we're going to abbreviate that, conjugate acid-base pairs. One's the acid and the other is the conjugate base. So what we want to do now is take a look at this worksheet 16.1. In this worksheet, you're being asked to write the formula for the conjugate base of the following acids. So you are being told that all three of these are acids, and we want to know what is the conjugate base of each one of these acids. To answer that question, to figure that out, we have to remember what's the definition of an acid. An acid means that it donates or it loses an H+. The conjugate base is the molecule that results after we've lost an H+. So for H2CO3, I don't want to write arrow there because that makes it seem like it's a reaction. For H2CO3, the conjugate base of that molecule will have one less hydrogen. So instead of H2CO3, it's just going to be HCO3. and it's also going to have the charge decreased by +1. We lose a +1 charge from the H+. So we go from HCO3, which is neutral, and we lose that positive charge. So now it's HCO3-. Let's try another one, NH4+. The conjugate base of NH4+. We have to lose a hydrogen, so we go from NH4 to NH3, and we lose a positive charge. We started out with one positive charge, that's the charge of NH4+, and we're going to subtract a positive charge. That's going to leave us with a neutral molecule. Let's do that math up here too. We started out with H2CO3, we started out with no charge, and then we lost a +1 charge, which leaves us with a -1 charge. One more of these, H2PO4-. First we have to lose a hydrogen, so we go from H2PO4- to HPO4, and then we have to think about our charge. We're starting out with a -1 charge, and we are losing +1. 1 minus 1 is -2. Now we're going to do the same thing. This time we have 3 bases, and we're being asked to write the formula of their conjugate acids. So we have to remember, what does it mean to be a base? A base is a molecule that will accept H+. That means that it's going to have 1 more hydrogen in the formula, and that also means that the charge will increase by +1. So for NH3, we want to add a hydrogen. Instead of NH3, it's going to be NH4, and our charge is going to go up. We're starting with a 0, no charge, and we're going to be adding a +1 charge. So the charge is going to become +1. For ClO3-, we have to add a hydrogen, so now it's going to be ClO3H, or you could write HClO3 if you wanted. The charge is going to go from -1. We're going to add a +1, so now it's going to have no charge, neutral charge. SO4-2-, we have to add a hydrogen, so now it's SO4H. The charge goes from 2-, add 1, now it's a -1 charge. It's really weird to write the hydrogens at the end of the formula. It's better if you write the hydrogens at the beginning, so instead of ClO3H, we should write HClO3. And for this guy, we should write HSO4-, because that's just how chemists normally write those formulas. But I don't think it matters that much where you put your hydrogen.